Hello everyone, so welcome to today's class. In today's class, we are going to see a very important chapter in physics, that is friction, and I'll be giving you very important notes. You can take down these important notes, and then once we have done with the notes, then we will try to solve the important numerical questions which are asked in different examinations like NDA, Group X, Group Y, SSR, and these physics problems which I'm going to do here, which will be even useful for the examinations like JEE examination, then KVPY examination. Okay, all this examination, this will be useful. So I hope that you have taken your notebook and you have taken your pen and ready with the important notes which I'm going to share before this class starts. Okay. Now here, what kind of questions will be asked when it comes to a chapter called as friction? Student, those who are writing examination like National Defense Academy, candidate, those who are writing examinations like National Defense Academy, here uh, they have a tendency of asking questions based on the basic fundamentals. For example, if there is a person standing on a floor, okay, he's standing on a floor and this floor is completely frictionless, or you can say there is no friction, it is made up of ice or some very soft surface, so this is frictionless. And now this person is standing, this person have to move forward or backward, so what can he do? There is no other supporting agent like rope, wall, etc. So now he has to move, so what can be done? These kind of questions like your basic ideas, basic principles are asked on the chapter of this friction. Okay, so keeping this in mind, we will also deal with important formulas and important numerical problems asked in different examination. So get ready with all your important study material or your notes, handwritten notes, and just cross check it if you have missed something in previous classes. To begin with, friction are of two types. You can draw this mind map. Friction are of two types. The first type is static friction and the another type is kinetic friction. Static friction and kinetic friction. When the object is in motion, when the object is in motion, I will call it as kinetic friction. And here, under kinetic friction, you have two types, that is sliding and then you have rolling. Now, the whole chapter of this friction will be based on this phenomenon. There will be different cases given when a ball is going to roll or when a box is going to slide, and what will happen if I keep it in an inclined place, what will happen if I keep a box in a horizontal surface. Okay, so this kind of questions will be asked in your examination. So I hope that you have drawn this mind map, that is friction. There are two types: static friction, kinetic, sliding and rolling. Fine. Now important laws of kinetic friction, very important laws of friction, laws of static friction. You can take this down in your notebook, which is very important. The first point here, laws of static friction, is the force of static friction. The force of static friction, the force of static friction is proportional to, is proportional to the normal force, is proportional to the normal force. You need to keep all these things in mind in order to solve the numericals. Next, second important point, frictional force is independent. Frictional force, frictional force is independent, is independent of the area of the area of contact, of the area of contact between two surfaces, between two surfaces. Okay, so these are the two important points under laws of static friction. And here, according to this important 2 points, we will derive an equation. Static force, that is static force, is less than the force applied. And now here this mu s stands for coefficient of static friction. This stands for coefficient of static friction. Coefficient of static friction. And here Fs will be maximum. Very important point. Fs, the static force, will be maximum when it has the maximum value. Is the formula you are going to use for maximum value of static friction. Maximum value of static friction. So these are the important points that you need to keep in mind when it comes to laws of static friction. Next, you have normal reaction on the horizontal surface. Fine. So now here we have to draw one important diagram. For example, if this is the flow and this is the box, okay, and imagine if this is the flow, horizontal surface, and here there is an object with a weight. So the force applied, here the reaction R is given as m into G, and here this will be considered as F. So kindly draw these two diagrams in your notebook so that it will be helpful in future to solve numericals. Okay, so this is inclined surface, this is the theta, this is the force here, and this is force F is equal to mg cos theta. F is equal to mg cos theta, and here this will be mg sin theta. Okay, so based on these two diagram, now let us try to write a sentence here explaining these diagrams. Normal reaction on the horizontal surface, normal reaction normal reaction on horizontal surface is equal to the weight, is equal to the weight, that is R is equal to mg. Remember this, very important. R is equal to mg, and that on inclined plane, and that on inclined plane is given as in the second diagram, that is R is equal to mg cos theta. R is equal to mg cos theta. Next, inclined plane, the gravitation pull, you can write down the gravitation pull in inclined plane. The gravitation pull in inclined plane is given as mg sin theta. Is given as mg sin theta. mg sin theta. Okay, so these are the important formulas. You can realize that when we solve numericals, problematic questions in friction, we are going to use this formula R is equal to mg when there is an horizontal surface. And now the second important formula here, this is the formula second important what we are going to use, mg cos theta, and the gravitation pull is equal to the mg sin theta. So these are important points that you need to keep in mind to solve the questions. Okay. Next, pushing and pulling a lawn roller. Pushing or pulling a lawn roller. So imagine if there is a circular object, imagine there is a lawn roller. So this is the mg, the reaction force here, and this is angle theta. This is given as p cos theta, and suppose if we are pushing it in this way, and you have another one more diagram, try to draw this diagram so that concepts will be clear. Next, you have here, this is the force, that is p cos theta, and there is another force, that is p, that is pull, and here this is one more force, it is p sin theta, and mg as usual it acts downwards. Okay, so what happens when we push a lawn roller? The force applied P has one component P sin theta in the vertically downward direction. You can see here it acts downward direction, and another component P cos theta in the horizontal direction. So here this is the horizontal direction force, and this is the vertical direction force here, P sin theta. So keeping this in mind, you need to solve some question. So when we push, the component P sin theta adds to the weight. When we are going to push the reaction force, what happens? P sin theta is going to add to the weight, thereby increasing the normal reaction. So you can say here that the reaction becomes mg plus P sin theta. Remember this formula directly. R is equal to mg plus P sin theta. Hence friction is equal to mu R. This is the reaction force. Okay, this is what happens when there is a condition of push. Kindly remember this. When I'm pushing it, I'm going to use this formula. Now, let us try to understand the other case when we pull the vertical component P sin theta is in upward direction. Okay, so when we are going to pull it, imagine this was P sin theta here, and here when we are going to pull it, the second case here in this case, so P sin theta is going to act upwards. Okay, so it acts in opposite to the weight, hence the reaction gives a minus sign. So now here when we are pulling it, I'm going to take R is equal to, mg minus P sin theta. R is equal to mg minus P sin theta. So these two formulas are very important in order to solve the numericals. Okay, many questions they are asking from this formulas. Next, so this is what happens when you are pushing or pulling a roller. Next important point, you have angle of friction. Very important. You can put a star mark. Very important. Angle of friction. Angle of friction. Now what happens here? Now imagine if there is a mass. Okay, imagine if there is a mass here, box here, and here there is a force acting. Okay, here there is a force acting. This is N and this is mg, and imagine if this is the angle, this is the theta. This is what we have to find, and force is acting in this word. So the formula given here, it is that tan phi is equal to F by N. F, we know that initially the first formula I have given, that is mu n, and mu is given as tan phi, that is the angle, coefficient of friction, and finally the angle can be found out, that is tan inverse of mu, that is coefficient of friction. Okay, so this formula is also very important to solve the questions, numerical questions. Okay, so next you have angle of repose. Next important point here in friction chapter, angle of repose. What is meant by angle of repose? It is the angle of inclined plane. So before that, let us try to draw one diagram. You can draw this diagram in your notebook and try to understand the basic concepts here. Imagine here this is the mass and this is an inclined plane with an angle alpha, and you know the mass and the gravitation, it acts downwards, so this I can take it as mg, and here this is the component, that is mg cos alpha, pushing force and pulling force we have seen just now, and this is the reaction force, and this is the force acting when it is sliding down, that is mg sine alpha, and this is the force. Okay, so now let us try to understand what is the meaning of angle of repose. It is angle of inclined plane with horizontal, that is alpha here, when the body placed in the inclined surface just begin to slide downwards. Okay, you can write it down in short. When body begins to, slide downwards, so that angle, okay, that angle is called angle of repose. That angle is called angle of repose. Angle of repose. Okay, so this is the horizontal surface, and imagine I have kept an inclined angle here alpha, and I'm keeping a box here. So here the box is not going to slide. But suppose if I take an horizontal surface here, imagine this is the horizontal surface, and slowly I start increasing the angle. But imagine in this case also the box is not going to slide. In third case, what I do with the same horizontal surface, I try to increase this angle. Okay, so now the box is here, definitely the box will start sliding. So what is that angle? This angle is called as angle of repose. This angle is called as angle of repose. Now let us try to understand some basic important formula. In equilibrium condition, the formula is mg cos alpha, and here we know the force mg sine alpha is equal to F, which is less than always compared to the maximum force. The angle of repose is equal to angle of friction. Okay, if what happens if angle of friction is equal to angle of angle of repose? So here we take a condition mg sine, this is angle of friction, and this is imagine angle of mg sine alpha. So this is mu mg cos, and finally we come across a formula. This is the formula to be used when it is in equilibrium. So here there are two conditions. The first condition you need to remember, when alpha is less than or equal to pi, the body is in equilibrium. The body is in equilibrium. The body is in equilibrium when both the alpha angle and the phi angle is less than or equal to. And if alpha is greater than phi, the body starts sliding down. The body starts sliding down. The body starts sliding down. Okay, so these are the two important things that you need to keep in mind before solving these kind of questions. Okay, so I hope that you understood from the beginning. We have two types of friction, that is static friction and kinetic friction. And then in kinetic friction we have seen there are two types of friction, that is sliding and rolling. And then we have seen little bit of what happens if a roller is rolled on a ground. That kind of theories we have seen it. And now next important point is minimum force required. Next is, you can take down minimum force required to move a body. Minimum force required to move a body on horizontal surface. On horizontal surface. On horizontal surface. What happens, suppose if this is the body and this is the horizontal surface, this is mg and this is n, and imagine now these are the forces acting, pushing or pulling. So here this is p cos theta, next you have an angle, this is p, and this is theta, and this is force. Okay, so let the force P is applied with an angle. So here this force P is applied with an angle theta with the horizontal. It is clear that the applied force has two effects on the system. Now try to understand, when I am applying the force P here, you can see from the diagram, when there is a body, when I am trying to apply the force, there are two things which is going to happen. The first is, it reduces the normal reaction. That means the frictional force is reduced. Okay, you can take down friction force is reduced. This is the first observation, friction force is reduced. And the second observation, the force P cos theta, it tends to move the body along the surface. You can take down force P cos theta tends to move the body, along the surface. along the surface. So these are the two things which happens. Now we'll have to understand how much force do we require. So you can take down this calculation, that is N is equal to mg minus p sine theta, and you can take down p. We also know that p cos theta is equal to the force applied, and now we can substitute that value, p into bracket cos theta plus mu sine theta, which is equal to mu mg. This is equation number 1. If we differentiate, with respect to theta, we get dp by d theta cos theta plus mu sine theta. Differentiating this, you get d by d theta cos theta plus sin theta mu is equal to 0. Next, for dp by d theta is equal to 0, p to be minimum, so now theta is equal to tan inverse of mu. That means tan theta is equal to the coefficient of the friction. So here you need to find directly the angle, and finally if you put the values of the minimum force, you get cos theta plus tan theta into sin theta, you get tan theta into mg, that is the reaction force. So p minimum is equal to mg sin theta, okay. It means that the body can be removed with least force if the applied angle of the friction is different. Okay, so this is the formula that we are going to use for the upcoming problems. I hope you understood. Let me take you back to the important slides here. So we started with this frictions. There are two types, static friction and kinetic friction. In kinetic friction there are sliding and rolling, and then the laws of static friction we have seen, important formulas. Then you have reaction force is equal to mg, and what happens if the box or the body is kept in an inclined surface, and what happens to the gravitation inclined pull, that is mg sin theta. Next, what happens to the lawn roller if they are rolled on the surface, and then the angle of friction we have seen, and then the angle of repose, the minimum angle or the inclination required for the body to slide, and then we have this minimum force required in the horizontal surface is this, that is mg sin theta. Fine. So that is what we have derived, how we have proved ourselves that mg sin theta is the minimum force required. So let us begin with the questions here, numericals. Question number 1, you can take down. I'll write it on the screen, you can take it down. A body is sliding down. On inclined inclined plane at a constant speed. Each and every word is important here. You have to find out the given datas. The relation between the coefficient of friction, the relation between coefficient of friction, mu, and the slope angle theta of the plane is. So you need to find it now. Options they have given mu cos theta, then B is mu is equal to sin theta, and C is mu is equal to tan theta, and option D is mu is equal to cot theta. Okay, so now you need to find out the answer with respect to the coefficient of friction mu and the slope of the angle. I hope you remember this diagram. We have drawn it. This is F, this is the reaction force R, and the sliding force is given as mg sine theta, and here this is the angle theta, and this is mg acting downwards, and this is the force mg cos theta. Okay, so we know that the reaction force here is R is equal to mg cos theta, and the sliding force is mg sin theta. Okay, so now we have to find out the value. We will do F by R is equal to mg sin theta divided by mg cos theta, mg sin theta by mg cos theta. Since we know that the coefficient of friction is equal to the force by the reaction force, so finally this mg and mg gets cancelled, so F by R is left with tan theta. That means mu is equal to tan theta. The option C is the right answer. Option C is the right answer. I hope you understood this question. The first numericals which we did was a very basic. The first question which we did is very basic and expected in your exams. Okay. Ready for the second question now? The second question, a force of a force of 750 Newton is applied. A force of 750 Newton is applied to a block, of mass 102 kg, 102 kg, to prevent it from sliding sliding on a plane with an angle of inclination, with an angle of inclination. The angle is given as 30 degree. All the data are important. Direct formulas we are going to use and solve the questions here. 30 degree with the horizontal. 30 degree with the horizontal. Next they have given, if the coefficient of static and kinetic friction, static and kinetic friction, if the coefficient of static and kinetic friction between the block and the plane, between the block and the plane are 0.4, and 0.2 respectively, then the frictional force acting on block, then the friction force acting on block is dash. Find out. I'll give you the options here. A is 750 Newton, B is 500 Newton, C is 350 Newton, and option D 250 Newton. Try to find out the answers. Direct formula. You can use this formula for this question. F is equal to mu mg cos theta. So here mu is 0.4. The mass they have given 102 kg, and g let us take as 10 here. Most of the time if they haven't specified, you can take 10. If the answers are in point, then you have to take 9.8. Now cos 30 is root 3 by 2. Cos 30 is root 3 by 2. Now when you try to solve this, you will get final answer as 350 Newton. That is option C is the right answer. 350 Newton is the right answer. I hope you understood the second question. Friction. So this is the formula which we are going to use. F is equal to mu mg cos theta. Next, third question. On the horizontal surface, on horizontal surface of a truck, on horizontal surface of a truck, a block of mass, a block of mass of 1 kg is placed is placed is placed and truck is moving with acceleration, and truck is moving is acceleration, a truck is moving with acceleration 5 meter per second square, 5 meter per second square. Then the frictional force on the block will be, then the frictional force then the frictional force on block will be, you have to find it out. Options: 5 Newton, 5 Newton, 6 Newton, 5.88 Newton, then you have 8 Newton. You can use this formula. The reaction goes direct, very easy. 0.6 mu is given, mass is 1 kg, and here you can take G as 9.8, or you can take 10. If you take 10, then it will be 6. Here it is specified, you have to take 9.8. So the final answer is 5.88 Newton. 5.88 Newton. Option C is the right answer. Option C is the right answer. Okay, ready for next question? Next question, question number 4. A body of 5 kg weight, a body of 5 kg weight kept on a rough kept on a inclined plane rough inclined plane of of angle 30 degree of angle 30 degree starts sliding with a constant velocity, starts sliding with a constant velocity. Then the coefficient of friction, then the coefficient of friction is dash. You have to find out mu value. Options are: A is 1 by root 3, option B 2 1 by root 3, option C root 3, and option D is 2 by 2 root 3. You can use this formula. Mu is equal to tan theta. We have to find the mu value. Theta is 30, So tan 30, 1 by root 3 is the answer. 1 by root 3, that is option A is the right answer. Very easy direct question. They may ask you this formula related questions in your exam. Okay. Question number 5. A car of mass a car of mass 1000 kg moves on a circular track of radius 20 meter. If the coefficient of friction if the coefficient if the coefficient of friction is 0.64, then the maximum velocity then the maximum velocity with which car can move with which car can move. Option A, 15 meter per second. Option B, 11.2 meter per second. Option C, 20 meter per second. Option D, 18 meter per second. And option E is 22.4 meter per second. Find out the answer. You can use this formula. V is equal to square root of the coefficient of static friction R into G. So the coefficient of static friction they have given 0.64 into the track radius they have given as 20 and G let us take it as 10. So finally when you substitute all the values and you calculate, the answer will be 11.2 meter per second. 11.2 meter per second, option B. Try to remember this formula. Questions in your exams will be based on this formula. Circular track kind of question. I hope you understood, and these are all previous year questions asked in different exams like Group X, etc. And let me tell you or give you one more example or one more problem which was asked in previous examination on the same formula. Let us try to do that. Next you have question number 6. Take down the question in your notebook so that during exam you can revise it. If a road is unbanked and and coefficient of friction between the road and the tires is 0.8 then the maximum speed with which an automobile can move around a curve of 84.5 meter radius without slipping. So find out. Let us take G is equal to 10 meter per second square, and options here given is 26 meter per second. Option B is 67.6 meter per second. Option C is 30 meter per second. Option D is 36.7 meter per second, and option E is 8.2 meter per second. Use the same formula. V is equal to mu into Rg, that is radius into G. Okay, I hope you all got the answer. So here it is 0.8 into 84.5 into 10. The final answer is 26 meter per second. That is option A is the right answer. Option A is the right answer. I hope you all got it. Fine. Going to the next question here. You have a block B. A block B is pushed. A block B is pushed momentarily along along a horizontal along a horizontal surface along a horizontal surface with an initial velocity v with an initial velocity v. If if mu is the coefficient if mu is the coefficient of sliding friction between B and the surface between B and the surface, block B will come to rest. Block B will come to rest after a time. You have to find out at what time it will come to rest. But look at the options, how they have given. V G mu. Next, G mu by V. Next, G by V. Next, V by G. So imagine this is the block B and this is the horizontal surface and this is the velocity. So you have to find out at what time. Find the value of t. Okay, let me give you the formula. We know F is equal to mu into mg, and from Newton's second law I know force is equal to mass into acceleration, that is mu into mg. And now I also know that mu a acceleration is velocity by time. So what happens is that I'm going to take mu, imagine this is mu, mg is equal to m into v by t here. So m gets cancelled, and finally when you substitute t value you get v mu g. So the time taken will be option A, V by mu G. V by mu G. Okay. So this was a kind of question asked in your previous year examination. These are all very easy questions. Just a minute. Okay. Next question you have, with increase in temperature, with increase in, this is NDA level question. With increase in temperature, the friction force between two surface, between two surface. Okay, so what happens? Let us see. Option A, they have given increases. Option B, remains same. Option C, decreases. And option D, becomes zero. Very easy. With increase in temperature, the friction force between two surfaces decreases. So this is a kind of question, very easy. Sometimes they may ask you in NDA examination. Next, last question for today. For a car, not to turn safely, on curved road, option A, what to do? The speed is slow. Next, option B, distance between tires is large. Distance between tire is large. Option C, center of gravity for car is low. Center of gravity for car is low. And option D, low friction force. Okay, so here they are asking in what situation the car will not turn safely. Okay, will not turn safely. So if the speed is slow, definitely the car will turn safely. Next, if the distance between tire is large, at that time also it will turn safely. And then you have center of gravity for car is low. That's also not a right answer. We want the car not to turn safely, so the option will be D, low friction force. So when there is no friction, the car will skid and it will not turn safely. So this is a kind of question asked in your examination. Okay, so this was a basic introduction of a chapter called as friction, and tomorrow we'll come up with a little higher level of questions, a problematic question from the chapter of friction. So try to revise all the basic formulas today which is taught, and again tomorrow we'll come up with some more interesting facts and important question which was asked in the previous examination. I hope you understood. If you have any doubt, you can just leave a comment in the comment section, and you can share this video to maximum of your friends those who are preparing for various examination. Thank you.